Okay, this is our mechatronics project. It's called Ramride. As you can tell, there's a ram on a ride. Consists of the controller and the base. There's wireless communication between the two. Okay, this is the controller box. As soon as we flip the power switch on it, it says "Welcome to Ramride," and it says to enter the code, you have to enter a 6-digit code, and it checks that versus a number that we entered in there. If you enter the wrong code, it says incorrect code. When you hit the right code, it says correct code, then go Rams. It says star equals increased speed, pound equals decreased speed, and 0 equals sound horn. It scrolls through these things continuously while we're running. And these are the motor control buttons, forward and reverse, for the two motors. Okay, there's a radio frequency link between this and this. It sends an 8-bit serial signal across from an encoder in the controller to a decoder in here in the base. I can go ahead and drive it around a little bit. Right on the back of that displays the speed in that 7-second LCD display. So I can go ahead and increase that or decrease that right from the controller. The horn is, we're outputting a square wave from a PIC of varying frequency through an amplifier board from a computer speaker to a small speaker that we have mounted inside the RAM. Our photocell that changes resistance with the amount of light. It's hooked up to a comparator and hooked up to 8 LEDs on either side and then 2 headlights. As you see, as we turn off the lights, it goes into a sequence where it sequentially lights the LEDs and then the headlights. And as soon as we turn the lights back on, they shut off. We also have interrupt buttons on the front of here, and they detect contact with a wall. So if I'm driving this forward and I hit a wall, it backs up and turns. This is the radio frequency receiver there with the decoder. This is powered by these AA batteries. It gets power at all times. Okay, the rest of the electronics and the motors are powered by this 7.2 volt battery. We have it running through a 5 volt regulator to the other electronics and then directly to the H bridge to run the motors. This is the motor control circuit here. It has 2 PICs controlling pulse width modulation for both of the motors. It has a counter PIC that updates the speed to each of the motors, and then there's an H bridge chip there. This is the PIC that outputs to the dual 7-segment LCD display. It outputs the speed from the counter PIC. This is our sound PIC that outputs the square wave that outputs to this amplifier board from a computer speaker to make the sound audible. And back here we have our comparator that takes the input from the photocell and outputs to this PIC that controls the 8 LEDs on the side and the 2 headlights.